Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Determine whether the following function is differentiable at the indicated value. So the function given to us is sine of mod x, and we've been asked to examine the differentiability at x equals 0, right? So again, this is a mod function. So we know how to express these mod functions, and let's write that out. F of x greater than or equal to 0, my mod x is x, right? So I will have to write that out first, and let's call, yeah. So I have my sine of x for x greater than or equal to 0, and then my mod x becomes minus x for x lesser than 0, right? So I will have it to write it as sine of bracket minus x for x less than 0, right? We know that sine of minus x, right, is always minus sine x, right? So I can rewrite this comfortably as minus sine x, right? Because sine of minus theta equals minus sine theta, or you can also call it as sine of minus x equals minus sine x, right? So I'm not going to go into the details of why. Uh, if you've done basic trigonometry, then this has to be very much familiar to you. So we are rewriting this function as sine x for x greater than or equal to 0 and minus sine x for x lesser than 0, right? And now we know how to proceed when we've been asked to find the differentiability at a particular point. So we will be starting off with our RHT. So let's write that down. So our RHD, which is our right-hand derivative, is f dashed of x naught plus equals h tending to 0, f of x naught plus h minus f of x naught divided by h, right? And in this case, our x naught is 0, so I can comfortably substitute wherever I have x naught, I can substitute it with a 0 first before proceeding to the next step. So this is what I have. I'm going to move to the next line to RHT is when x naught takes a value. So my RHD is when x takes a value which is greater than 0 by an infinitesimal h, limit h tending to 0. And therefore, which is that equation I will have to pick up when I represent f of 0 plus h? I will have to pick up sine x, right? And what do I have to do? I will have to replace my x by 0 plus h, which is nothing but h, right? So my sine of x becomes sine of 0 plus h, which is nothing but a sine h. So I can straight away write it as sine h. So this is the first part of the numerator. And my second part of the numerator is f of 0, which is sine 0, which is nothing but minus of 0. And I divide that by h, right? Now we are left with sine h by h, right? And in fact, this is the first uh, formula under limit that we studied. As limit h tending to 0, my sine h by h tends to 1, right? So we're not going to go into proof behind this particular formula here, but we know for sure that limit h tending to 0, sine h by h equals 1. So there we have our RHD. I'm going to jump to my LHD now. My RHD is finite. So let's jump to our LHD. So there I have my LHT, which is f dashed of x naught minus equal to limit h tending to 0, f of x naught minus h minus f of x naught by minus h, right? So what is our x naught? My x naught is 0. So I can replace my x naught with 0 wherever I see an x naught. And move to the next line, evaluate our LHD. What is my f of 0 minus h? Is when x is lesser than 0 by an infinitesimal h tending to 0, right? So in this case, I will have to go with the second equation, which is minus x, because x in this case is going to be lesser than 0. And I will have to replace my x by 0 minus h, right? And what is that? I will have my minus sine x, and then I have my minus of 0 minus h. Minus f of 0 is sine 0, which is a 0. So I can call it 0 here. And I'm left with minus of sine of 0 minus h divided by minus h, right? So that's what I have. And what is my sine of 0 minus h? It is nothing but sine of minus h. And what is my sine of minus h? Is nothing but my minus sine h, right? So which means I can comfortably write this as minus 1 into sine of minus h, which means I have minus 1 into minus sine h, which is nothing but my sine h, right? So I have minus of sine of minus h divided by h, which is nothing but my sine h divided by, I'm sorry, minus h, which is nothing but my two negatives cancel out, and I'm left with sine h by minus h, which is again, you know, minus of sin h by h, which is minus 1, right? So I'm left with minus 1. So we've evaluated our LHD, we've evaluated our RHD. Both of them are finite, they exist, but we see that my RHD is 1 and my LHD is minus 1, right? And therefore, we know what the answer is. My LHD not equal to RHD, not equal to RHD, and therefore function is not differentiable at x equals 0, right? So that's how we go about solving this problem. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.